Hello everybody. Today we will review the major concept behind the new ECO application and the main terms that we are using. We will start by creating a parting subassembly. This is a new option in the parting setup wizard. And the new subassembly will come ready with a layout file, and it is ready to receive our work part, which is exactly what we will do now. And of course, we will be creating a copy of the work part with a shrinkage factor and a scale feature. Now there are two new options here. One is to add a new parting surface part automatically, and we can adjust its name. And another one, which is very important for the ECO application, is to add the master part as well as its copy. So what we got now is our work part, the parting surface part, and a new subassembly called ECO with our master copy, and any ECO part that we will bring in will go into this subassembly. Of course, normally we would now start to do our quick split work and probably also some parting surface creation, and at some point we will get an ECO from our customer. And when we get it, we will start the ECO process. So I will click the ECO tree button here, and I want to talk a little bit about the structure of the tree. First of all operations are available from the tree. You can also get them from the menu over here in the ECO tools. The structure is this. We have our basic root, and under it we create folders. Each folder represents one ECO that we got from the customer. Under each ECO folder, we can make several comparisons. We can make a comparison between the old ECO and the new ECO and the work part, the new ECO and any other part in the mold. And it is important to understand that exactly the same process that we are doing here with the work part can be done in a mature mold with the core insert or the cavity insert or the slider or the lifter or any other part. We will now bring in our ECO part, or as we call it, the comparison part. Now I want to take a special look at the options that we have here. The system allows us to create an ECO folder because we're bringing in a new ECO part, and also to create a comparison for it. We will see what it means in a minute. And I want to take a special look at this button with the red text over here. So what it says is previous modification, and if we stand on it, we will get a tooltip saying select the previous modification part, and it will also tell us that usually it will be the master part or the previous ECO part. Now you can see the text is in red. This means the system cannot choose automatically the part for us, and we will pick the work part, but the work part was not selected. The system automatically knows to select the simple master copy part, which is our master part. So the system looks for the last ECO part that was there. In this case, it is the master. When we get an automatic selection from the system, the text will become purple. If we go in and change it manually, the text will become black. Now, once we selected our reference part, we got the correct scale over here, which is exactly the scale that we used for this part. And when we will click OK, we will get a new folder, and in it we already have one comparison. This comparison is between the master part and ECO1 part. Let's get rid of our old folder and look at this comparison. What we see here is that the change is that the text ECO1 was added over here. So this gives us a picture of what was changed in the ECO part that we got. Now we want to make our actual comparison, which will always be a comparison between the ECO part that we got and the part we want to update. In this case, it will be, of course, the work part, because we always want to know if the changes that we got from the customer were applied to the part that we want to update. So I'm making a new comparison, and now the system is asking me what I want to compare with what. So I have two buttons here, again with purple text. One is saying receiving part. This is the part that will receive the change. Normally it will be the work part or the core or cavity insert and so on. The second part is called modification part. This is the modification bearing part, the part that brings in the modification, and this will be usually our new ECO part. Note that the system again selected automatically the correct parts to be placed in both buttons. Now let's start the analysis, and as we can expect, the results are pretty similar to what we saw before because the master part and the work part are exactly the same. And so we got our new comparison over here, and now we want to apply the change to the work part. So we have a new option called Replace Master. This option will replace the part that is imported into the work part. Instead of using the master part, we will use the ECO part. It is a very quick process, and let's look only at the work part. We can see the change is applied. Of course, these faces do not have their quick split attribute yet. And we can also see an exclamation mark here. This exclamation mark says that something has changed and the compare is no longer accurate. Now you can see that we don't have this exclamation mark here because this is a comparison of the master and ECO1 and they did not change. The only part that has changed is the work part. So let's update this comparison, and the system will tell us that after we made the change, it cannot find any differences between the work part and ECO1, which means all of our changes were applied to the work part. And it will also ask us if we want to mark the folder as done. And we will click yes. And you can see that we got this done marking over here, which means this ECO was applied correctly. Let's say we have continued working on our part, and now we got another ECO from our customer. We will ask the system to add a comparison part, of course ECO2. Again, we select a reference part in the area. The system will know to select ECO1 as our previous modification part, and we get a new folder for the new ECO and a comparison that shows us the actual change between ECO1 and ECO2. And we can see that the text ECO1 was removed and the text ECO2 was added. And now we will ask to add another comparison, this time of course between the work and ECO2. Again, it is the same change because the work part is now exactly the same as the ECO1 part. Now we want to apply the change in a different way. We will use a new tool called Replace Faces. What this tool does is it allows us to select faces to be removed and faces to be added. Now, if the boundaries of the two groups are matching, we will get this mark that says that a stitch can be applied after the faces are removed and added, and we will get a closed object. If we will remove some faces, we will get a marking showing us where we have discrepancies between the boundaries. Of course, we will bring them back in. We get the marking that everything is okay, and the replace was done. And if we will look only at the work part, we can see that it is closed and looks well, and that the change is applied. Again, we get this exclamation mark telling us that there was a change, and if we will ask to update the comparison, it will tell us that there are no differences between ECO2 and the work part, and it will mark the folder as done. This was a very simple example of how we apply the ECOs when there is no mending. And now we will go to a slightly more complex example where mending is involved. For our ECO with mending project, we will use the same method that we used before. We will create a parting subassembly, and into it we will bring our work part. So we selected our master. We can play with the shrinkage, and of course we are bringing in our master part into the ECO folder. And we will do some mending work on the work part. We will add some draft angles. And some rounds. Now let's say we have continued working and now we got our ECO from our customer. We will open the ECO tree and add a comparison part. ECO1, of course, reference, and of course we get the actual change folder. And we can examine the change that we got. What do we have here? The text ECO1 was added and this boss was removed. We will run a comparison, of course, between the work part and ECO1, and now we got a slightly different result. The system also marks this area because the ribs that we have changed are indeed different between the ECO1 and the work part. But of course there is no real change in this area. So how do we tell the system to ignore our mending work? Well, we have an additional option here. Instead of show all changes, we can ask to show only unapplied changes since the previous modification. What this will do is it will ask us to specify what was the previous modification part. As usually, it is selected automatically and selected well. And if we start the analysis, we can see that the system completely disregards the changes in this area and only shows us the correct added and removed faces. Let's understand how this is done. First of all, for this explanation, let's assume that the ECO we receive is ECO number 5, and the previous ECO was well implemented. Now the previous ECO can be ECO4, ECO3, if we skipped one, or any other ECO, it doesn't matter as long as we tell the system what is the previous ECO. And for this discussion, we will assume it was ECO4. So how did we get from this, from all this mess, including the mending, to this, to a state where we see only the changes that are correct? We do it by changing the question. Instead of asking only if ECO5 is exactly the same as the work part, we now look only at the changes between ECO4 and ECO5. Let's take a closer look without the surrounding faces. We only look at these changes and ask if they are applied in the work part. More specifically, we ask if the faces to be removed were indeed removed from the work part, and the answer right now is no, they are still there, so they should appear in our comparison. And we also ask if the faces that were recognized as faces to be added were indeed added in the work part, and again the answer is no, so these faces still need to appear in our comparison. Let's see what happens if we implement one of the changes manually. I will create this comparison. You can see we have a marking here of the number 3, and the same over here telling us that this comparison also has a previous modification part involved. Now let's activate the work part, and for example, let's remove the boss. Let's look again at the questions that we asked before. If we want to look at what we call the comparison between ECO4 and ECO5, this is this comparison, the actual change. And what needs to be done is the blue faces need to be added and the red faces need to be removed. Now, when we look at our second comparison, we can ask these questions. Were the blue faces added? No, so they should still appear. Were the red faces removed? Yes, and therefore they have disappeared. Since I want to apply the change using replace master, I will remove this operation and will ask for replace master with ECO1. And now everything is complete. If I will ask to update the comparison, the system will tell me everything is okay. Now I want to take a closer look at this and see that if we would not take the previous comparison part into account, the system would not tell us that the change is complete. Only when we say check only the changes from the previous change will we get the message telling us everything is complete, and of course it will mark the change as done. Now I want to make another small change in the part. I want to move one of the ribs. Let's say something like this, a very small change. And let's say that now I have received another ECO part from my customer. So of course the next operation is add another comparison part, select the reference, and there it is. Let's try to understand what has changed now. Okay, so of course we can see, let's just hide the work part. We can see the text ECO1 was removed, ECO2 was added, and it looks like this rib was moved from here to here. Okay, let's make the real comparison now. Add another comparison. And let's see what we get here. So when comparing the work part with ECO2, we get these changes, of course, ECO1 and ECO2. We can see that this rib was moved more or less, and we can see these mending changes. One of the rib has moved slightly, and we have the taper and rounds here. So as before, we will ask the system to ignore the mending by telling it only look at the changes between ECO1 and ECO2. Let's see what happens. Okay, we get a very good result, or so it seems. ECO1 should be removed, ECO2 should be added, and the rib should be moved, but something is missing. We can see the blue faces, but we can't see the red faces. We get some indication over here with these orange edges, but it's not clear why the red faces are not there. So let's see how we answer the questions that we asked before. Let's start with the blue faces. Were the faces to be added indeed added to the work part? Again, we only look at what we call ECO4 to ECO5. So the answer is, of course, no. We don't have these faces over here, so they were not added, and that's why they appear. This is perfectly okay. Then we asked, were the faces to be removed, indeed removed from the work part? And it would seem that the answer is no, because the rib is still there, right? Let's take a closer look. Oh, now it is clear that it is not exactly the same rib, and if the system looks at the faces and asks, has these faces been removed? The answer would be yes, the faces were removed, because we can't find faces that are similar to the red ones in the work part. Now, we know that it is more or less the same rib, so if we could make this test a little bit looser, if we could tell the system it is okay to have some distance between the faces, then maybe the answer would change. So let's see how we do that. We have another option here. Right now it says exact compare of unapplied changes, but we can change it to rough compare of unapplied changes, and we can specify the distance that is allowed between faces that are supposed to be removed or added and the faces of the work part. So let's start the analysis now. Oh, now we get some red faces, and if we will make this a little bigger, we even get some more red faces. So this way we can manage an area that has changes both resulting from mending that we did and from changes that we got from our customer through the ECO. This way we can see both changes but still ignore other changes that are happening over here. And the reason I moved this rib by 1 millimeter is that I wanted you to see that although I allow these 2 millimeter gaps, these changes are not recognized because they are not at all changes between ECO1 and ECO2, or in the previous example, ECO4 and ECO5. So the system will ignore any mending change that we did, except for ones that have happened in an area where there is a real change between the current ECO and the previous ECO. What we want to do now is, of course, to implement the change, the movement of the rib, and I will naturally use replace master here. We will replace it in the work part with ECO2. And it is done, the rib is moved. Let's try to see what we have here. And I want to start the comparison without compensating for mending, just to see what we have here. So we can see that the rib has moved, but we can also see that all the faces are different because they got the mending, the draft angle and the rounds. Now let's make the basic compensation for mending without the rough compare. And we can see that we still have these blue faces here, again, because these blue faces cannot be found in the work part because of the draft angle and the rounds. But if we make it a bit rougher, let's say 2 millimeters, we can see we still have some marking here. And if we make it 3 millimeters, we get the message that is saying that everything is okay. Do you want to mark the folder as done? Of course, we will say yes. And this folder is done. And this concludes this demo of the basic methods and terms of the ECO process in E11. Thank you very much for watching.